Welcome to the next chapter of the Pragmatic REST APIs course, where we will slowly start building our REST API. We will start with an introduction to HTTP methods. I'm going to explain what they are, what are some of the most popular HTTP methods that your API should support, and what are the semantics between the different HTTP methods that we have. Then we're going to continue our discussion into HTTP status codes. I will introduce you to the status code groups and what each group represents, and then I'm going to introduce you to some best practices when it comes to designing RESTful APIs. As with any take on best practices, you should take this with a grain of salt, but more on this in an upcoming lesson. Then we're going to implement support in our RESTful API for the get, post, put, delete, and patch HTTP methods. I will explain in detail the functionality that our API will provide using these specific HTTP methods, and of course I'll share any caveats that you should know and drawbacks that you need to be aware of. After implementing support for the standard HTTP methods in our API, we're going to tackle some more advanced topics, and one of them will be working with child resources. Here we have to pay attention to a few things, for example, how we structure our URIs and how we implement the logic inside of our code. The next thing we need to do is to make our API more reliable in the face of client errors and anything unexpected that might happen while executing an API request. And for that reason, we're going to implement validation and error handling inside of our REST API. Then we're going to cover a couple of topics that relate to querying our REST API, and these are going to be searching and filtering our resources, implementing support for sorting and pagination of our API responses, and we're going to finish off with a lesson about data shaping, where I'll show you how you can implement support for your clients to dictate what the response of the API should look like. So that's it for this brief introduction. Now let's move on to our next lesson, where I will talk about HTTP methods. What are HTTP methods and why do we need them? That is what I'm going to answer in this lesson. The HTTP standard defines a set of HTTP methods that indicate what is the desired action on the server when we send a request with a given method using a URI. HTTP methods are defined in detail in the HTTP semantics RFC, and I'm going to leave a link to it right under this video if you want to review it. Another common name you will find for HTTP methods is HTTP verbs, although this isn't part of the specification, so I will not be using it. I will be referring to them as HTTP methods. So let's cover the most common HTTP methods. We have get, post, put, delete, and then patch. You have probably already heard about some of them, or most of them, so let's try to understand what each of these HTTP methods means. We use the get HTTP method when we want to request a resource from the REST API. We use post for creating a resource. We use put for updating a resource, where the update in this case is a complete replacement of the resource on the server. This is a bit different from patch, but more on that in a moment. We have the delete HTTP method when we want to remove a resource or delete it, and then we have patch, which is meant to be used for partial updates on a resource. Now, when it comes to using these in practice, you will often find that patch isn't frequently used, and instead we use the put HTTP method for applying updates, whereas patch is typically not implemented. However, I'm going to cover both put and patch, and I'm going to explain what are the differences between them. Other than the standard set of HTTP methods, you may also encounter a few more. One of them is the head HTTP method, which is more or less identical to a GET request, but the difference is that the response doesn't contain a response body. A common use case for using the head HTTP method is cache validation, or checking if a resource exists when it's computationally expensive to transfer the resource from the server to the client. An example of this might be checking if a large file exists on the server. By not returning the response body, the HTTP method saves us some network bandwidth. We also have the options HTTP method, which simply lists the supported set of HTTP methods on a given resource. This can be useful for discoverability when you want to check which HTTP methods are supported for a given resource. If you want to implement head and options inside of your ASP.NET Core applications, this is relatively simple. For implementing head, it's enough to decorate your get endpoints with the HTTP head attribute. This will allow head requests to reach your controller without transmitting the response body back to the client. When it comes to supporting the options HTTP method, you can define an options method on your controller instance, decorated with an HTTP options attribute, and then in the response headers, append an allow header that lists the supported set of HTTP methods. So far, we were discussing the semantics of HTTP methods and when each one of them is appropriate to be used. But HTTP methods also have other important qualities such as idempotence and safety. So let's try to define these in simple terms. An HTTP method is safe if it has no intended side effects on the server. An HTTP method is idempotent if sending multiple identical requests to a given resource have the same effect as sending a single request. So now let's do a comparison of these standard HTTP methods in terms of being safe, idempotent, and I'm also going to introduce another quality called cacheable. Let's start with the get method, which is safe, idempotent, and cacheable. So let me explain this. Get is a safe method because it doesn't change anything on the server. We can send multiple get requests and obtain the same response, which is why it's also idempotent. And then the response of a get request can be cached if it's marked as cacheable using the respective headers. The post HTTP method, on the other hand, is neither safe nor idempotent nor cacheable. So let's explain this. Post is not safe because it creates a resource. It alters the server state. It is not idempotent because if I send multiple post requests with the same request body, I will end up creating multiple resources. Now, even though this is true for most cases, we could also implement our post requests to be idempotent by manually checking if a resource with the same URI already exists. A typical use case for this could be user registration on your platform, where you want to enforce a business rule that all emails inside of your system have to be unique. So in that regard, if I send multiple post requests with the same email, only one of them will alter the server state and create a new resource, but any subsequent request should encounter a failure. Then we have the put HTTP method, which isn't safe because it updates a resource on our server and therefore changes the server state, but it can be idempotent. Let me explain this. When we update or replace a resource with the same request, we will only effectively change the state on the server once on the first request. Any subsequent requests using the same request will not further change the state on the server, which is why put is considered idempotent. Put, like post, is also not cacheable. Now let's take a look at the delete method. You can see it has the same qualities as a put. It is not safe because it deletes a resource from our server. It is idempotent because deleting a resource once is effectively the same like deleting it 10 times. We can't really delete something if it's not there. Now, there are some nuances here that we're going to discuss when we talk about deleting resources more, but for now, let's leave it at that. And the delete method is also not cacheable. And in the end, we have patch, which is neither safe nor idempotent nor cacheable, and it has the same qualities as a post. It's not safe because it's performing an update. It's not idempotent because sending the same patch request multiple times could change the state on the server. I will talk more about this when we implement HTTP patch, but let me give you a simple example. Let's say that the patch operation is adding an element to a collection. If we were to send the same patch request multiple times, we would end up adding multiple elements to a given collection, and this is not idempotent. And the response of a patch request is also not cacheable. One guideline I can give you when it comes to using HTTP methods is try to be consistent. HTTP methods have some semantics assigned to them, and each one should produce an expected outcome on the server. Now, that being said, there are exceptions to any rule or guideline. Let me give you a practical example. Let's say I'm sending a GET request to fetch some resource, and I have a very large number of query parameters. There is a maximum length of a URL, and if I keep appending my query parameters, I may run into this constraint. This can be even more troublesome if your request is being relayed through a set of proxies before it reaches the server, and you may run into some unexpected issues. So in that regard, it is completely acceptable to send a POST request with a request body for fetching some data from the server. By using this approach, we do not run into any limitations that we might have with using query parameters, and we are still providing the functional requirement that we need, which is retrieving data from a server. So even though this isn't REST compliant, it's absolutely the right thing to do. So as I said, be consistent, but also be pragmatic depending on your situation. So now that we have explained HTTP methods, we have to continue our discussion with the next logical step, which is HTTP status codes.